Here we'll use this graph to try to deduce what a rational function is. We'll begin with the domain. We can see on our graph that we have a vertical asymptote at -4. We can also see that we have a hole at x equals 0. Anytime that you have a vertical asymptote or a hole, that will create a split in your domain. With this in mind, we'll draw a number line and we'll put open circles at -4 and 0. This will split our domain into 3 pieces, A, B, and C. We can say that piece A will be -infinity to -4, union piece B, which is -4 to 0, union piece C, which is 0 to infinity. This will give us our domain. Previously, we just marked the hole at this open circle, which is on the y-axis. I'll box it in red now. The position of this hole is 0, 1. We'll say that's our hole. We have 2 x-intercepts, which I'm going to mark with closed circles. We have one at -5 and another one at -1. Therefore, we'll say our x-intercepts are -5, 0 and -1, 0. Now notice our y-intercept would be the position where the graph crosses the y-axis. We would ordinarily say that that would be 0, 1. However, this 0, 1 is also a hole, and it's not possible to be a hole and a y-intercept at the same time. Therefore, we'll cross that out, and we'll say that the y-intercept does not exist. If that was a closed circle, it would exist at 0, 1. But since it's open, we'll say DNE. We also have a vertical asymptote at x equals -4. That's represented by the orange line next to this -4. With this information, let's try to figure out what the function is. To write our function, we'll start with the division bar, and then we'll examine our x-intercepts. Any x-intercepts will give us information about what will go on top. Therefore, we'll start with our x-intercepts, and we'll say x equals -5. That's the x-coordinate of the first x-intercept. We'll also say x equals -1. Now, we'll take the -5 and add 5 to both sides to cancel out the -5. When we do the operation, we'll get x plus 5 on the left and 0 on the right. This will be our first term that goes on the top of our division bar. We'll do the same with -1. If we add 1 to both sides, we'll get x plus 1 on the left side of this equation and 0 on the right. This means x plus 1 will also go on top. Now, the vertical asymptotes will give us information about the bottom. So here we can start with x equals -4. If we add 4 to both sides, we'll end up with x plus 4 on the left equals 0. We can put x plus 4 on the bottom now. Now the holes will give us information about the top and the bottom. Whatever answer we get from doing the same process with the holes will go on the top and the bottom. Therefore, we'll begin with our x-coordinate from the hole. Make sure you only use the x-coordinate, that's 0. So we'll begin with x equals 0. Now, since this already equals 0, there's nothing else we have to do here. The x, this lone monomial, will go on the top and bottom. Therefore, we already have most of our work done. The only thing we don't know is the leading coefficient. So I'll write the letter A in front of this to show that we don't know what the leading coefficient is, and then we'll find that leading coefficient on the next page. In order to find the leading coefficient, we'll begin by canceling out the holes and then looking to the y-intercept. Since our whole gave us the x term, we'll cross out the x on the top and the bottom and look at what's left. We'll say y is equal to a times x plus 5 times x plus 1 over x plus 4. And now our y-intercept is the point 0, 1, at least that's what it would have been if it wasn't d and e. We can still use that 0, 1 where we can let x equal 0 and let y equal 1. So where the y is located now, we'll say 1. And everywhere we see an x, we'll place a 0 in that position. Therefore, we'll have a times 0 plus 5, which is 5, 0 plus 1, which is 1, over 0 plus 4, which is 4. If we simplify our equation, we 1 equals a times 5 over 4. Then we will multiply by the reciprocal of that fraction to find a. The reciprocal of 5/4 is 4/5. When we multiply by 4/5 on both sides, we find that a is equal to 4/5. This is because the 5/4 and the 4/5 on the right cancel out completely, leaving only a. And then 4/5 times 1 is still 4/5. This will give us our a value. Therefore, our rational function will look like this at the end. We'll say y equals 4 over 5. We'll place the x times x plus 5 times x plus 1. This will be over x plus 4. And also with this x that was canceled out, we'll put that next to the 5. This will be our final rational function. We'll include the x because we must include the whole in our final answer, even though we did cancel it out in order to find a.